Hello everyone, this is team AP050. To demonstrate our project Smart and Sustainable Agriculture using FPGA, we have prepared a land of 2 into 3 square meters land in our college and planted corn crop. Initially, we have executed all our tasks on paddy crop like crop recommendation, fertilizer recommendation, smart irrigation, weed detection and pest protection. Since it is an odd season for paddy in India, we have chosen corn crop to demonstrate our project. We executed all our tasks on corn crop and executed successfully. Sensors testing, soil collection. For testing all the sensors that we are using in our project, we have collected soil samples. pH sensor. Initially, we check the pH of water. Then after, we check the pH of soil. Electric conductivity and soil temperature sensor. Here we are collecting the readings of EC and soil temperature sensor. Soil moisture sensor. Initially, we kept the soil moisture sensor on a dry place and we can observe there is less amount of moisture. Now we kept the soil moisture sensor in our wet soil. We can observe the increasing in soil moisture. Water level sensor. Initially we kept the water level sensor on a dry paper. We can observe the readings. Now we kept the water level sensor on a wet soil and pour some water. And we can observe the increase in the water level. Setup introduction. For the ease of portability and installation to farmer, we have modeled a hardware metal frame of 6 feet height that can hold a solar panel and fiberglass box which consists of control part in a single stand. We have redesigned our previous prototype with this new fiberglass box and arranged all the components in 3 layers. In the top layer we have kept D10 nano board, motor driver and USB hub. In the second layer we have kept Arduino, and we have designed our own generalized PCB for connecting Arduino and sensor modules. And the down layer we have kept the power sources like a power bank for D10 nano and a 9 volts lithium ion battery for sensors. Through this solar charge controller, farmer can see how much voltage is receiving from solar panel. As through the camera, we will send picture of crop at different time intervals. Smart irrigation. Whenever we install sensors into the field and start executing our project, the sensor data will be reading into the terminal and it compares with the threshold values of the water level and moisture and will start irrigation when it required water to the crop. And whenever it contains sufficient amount of water, the motor will stop again and remains constant. Crop recommendation. After installing our prototype in field, farmer need to register his crop. Whenever he registers his crop, our model will store the date of plantation and performs necessary actions like fertilizer recommendation, crop recommendation, weed detection. Before weed detection and after weed detection. After performing weed detection, we can observe small boxes with weed. Thus, farmer can identify weed in crop. Disease prediction. Whenever farmer upload a picture of a plant which is affected by some pests or diseases, our model will detect whether which type of disease it is and suggest necessary measures like cultural control, chemical control and biological control.